Hello students, today we are going to study few more examples on the topic relation and functions from the exercise 1.1. Let me begin with the second question. Show that the relation R in the set of real numbers are defined as. R is a set of real numbers and this R is a relation defined as R is equal to order pair a comma b such that a is less than or equal to b square. The first element is less than or equal to the second square of the second element. Is neither reflexive nor symmetric nor transitive. Dear students, let me begin with the solution of this problem. Given that R is the set of real numbers and it is defined as, that is, relation is defined as R is equal to a comma b since or such that a is less than or equal to square of the second number. Since R is an infinite set, therefore it is very difficult to represent the set builder form in the roster form. That's why let me generalize the reflexivity, symmetricity and transitivity. Reflexive relation. For all x belongs to R, or you can take a belongs to R as x comma x is not belong to R because x is never be less than or equal to square of the same number. For example, suppose x is 1 by 2. We have to show that one example where the relation reflexive is not possible. Suppose if I take x is equal to 1 by 2, then the square of this number is 1 by 4. Obviously 1 by 2 is greater than 1 by 4, but 1 by 2 is never be less than or equal to 1 by 4. Therefore this is an best example to show that the relation is not reflexive. This is x is greater than x square, but x is not less than or equal to x square. Therefore R is not reflexive. Symmetric relation. To define the symmetricity, we need two elements belongs to the given set. For all x comma y belongs to the given set R, if the order pair x comma y belongs to R, then y comma x is not belongs to R. If it is belongs to R, the relation is called symmetric relation. But y comma x is not belongs to R. That is, x is less than or equal to y square, but y is never be less than or equal to x square. There are the few numbers which does not satisfy this condition. For example, x is equal to 2 and y is equal to 5. Then 2 is less than or equal to 25. That is 5 square is 25. But 5 is not less than or equal to 2 square. That is 4. 5 is not less than or equal to 4. Therefore, R is not symmetric. Transitive relation. To define the transitivity, we need three elements belongs to the given set. For all x comma y comma z belongs to R, if order pair x comma y belongs to R and y comma z belongs to R, then x comma z is not belongs to R. As x is less than or equal to y square and y is less than or equal to z square, but x is not less than or equal to z square. For example, if x is 3, y is minus 2 and c is, that is z is minus 1. Dear students, instead of c, we can take this element as z. Z is equal to minus 1. Then 3 is less than or equal to minus 2 square. That is 4. 3 is less than or equal to 4. That is true. Minus 2 is also less than or equal to 1. That is minus 1 square is 1. But the 3 is not less than or equal to 1 square, which is not possible. Therefore R is not transitive. Therefore the relation R is neither reflexive nor symmetric nor transitive. This is one more example which does not satisfy the reflexivity, symmetricity and transitivity. Dear students, moving to the next question. Question number 3. Check whether the relation R defined in the set, one set is given for us, that is 1, 2, 3, 4, 5, 6, And the relation is defined as R is equal to A comma B such that second element is equal to the first element plus 1. Is reflexive, symmetric or transitive? We have to decide, we have to check, we have to determine whether the given relation is reflexive, symmetric or transitive. This question was given in the supplementary examination 2017. Let me begin with the solution. Let A is a set containing elements 1, 2, 3, 4, 5, 6 which is defined as. Since the set is a finite set, we obtain the relation in the roster form. The relation R in the set builder form is given for us A comma B such that the second element is equal to 1 more than the first element, that is A plus 1. This is the set builder form. Since the set, if A is 1, B is 1 plus 1, that is 2. If A is 2, B is 3, that is 2 plus 1. If A is 3, B is 4. If A is 4, B is 5. And if B is 5, if A is 5, B is 6. But if A is 6, B is 7, which is not there in the A. Therefore, the only 5, 6 elements will be taken in the roster form. Now, this relation is nothing but in a roster form. To check whether this relation is reflexive, symmetric or transitive. Reflexive relation. For all A belongs to capital A, as A comma A is not belongs to R. There are no elements for all elements of the set A. For all elements of the set A, there are no elements or no order pairs like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, which is not there in the relation R. Therefore, R is not reflexive. Symmetricity. For all A comma B belongs to capital A, if A comma B belongs to R, then its reverse order pair must be there in the R. If I take the order pair 1 comma 2, there is no such order pair 2 comma 1 in the given relation. Therefore, it is not belongs to R. If I take 2 comma 3, there is no such order pair which is reverse order pair of this given. 3 comma 2 is not there in this R. Likewise, 3, 4, 4, 5, 5, 6. The reverse order pairs are not there in the relation. That's why we wrote here B comma A is not belongs to the relation. Therefore, the given relation is not a symmetric relation. Transitive relation. To define the transitivity, one should have the three elements of the given set. For all A comma B comma C belongs to capital A, if A comma B belongs to R and B comma C belongs to R, then A comma C is not belongs to R. Therefore, R is not transitive relation. Suppose if B is A plus 1 and C is B plus 1, this implies that C is equal to B is nothing but A plus 1, that is A plus 1 plus 1, which is not belongs to again a plus 1. Therefore, the relation is not a transitive relation. Therefore, the given relation is once again R is neither reflexive, symmetric nor transitive. Moving to the next question, which are important for the exam point of view. Check whether the relation R in the relation R in the set of real number R defined by R is equal to A comma B such that A is less than or equal to B cube is reflexive, symmetric or transitive. R be the set of real numbers. R is equal to A comma B such that A is less than or equal to B cube. Reflexive relation. For all A belongs to the set of real number, as A comma A is not belongs to R, because the relation between A and A is less than or equal to cube of the second. For example, suppose if I take A is 1 by 2, then A cube is, dear students, here we have the element A cube. A cube is 1 by 2, 8. But 1 by 2 is greater than 1 by 8. 1 by 8 is not greater than or equal to 1 by 2. Therefore, this condition does not satisfy. Hence, the relation is not reflexive. 1 by 2 is not less than or equal to 1 by 8. Therefore, the relation is not reflexive. Symmetric relation. For all A comma B belongs to R, if A comma B belongs to R, then B comma A is not belongs to R. For example, if A is 1 and B is 2, then A is less than or equal to cube of the second number, that is 2 cube. 1 is less than or equal to 8. but 2 is not less than or equal to 1, because 2 is less than or equal to 1 cube. 1 cube is again 1. Therefore 2 is not less than or equal to 1. Here, but 2 is not less than or equal to 1 cube. Hence this relation is not symmetric relation, because a comma b belongs to R but b comma a is not belongs to R. Hence the relation is not a symmetric relation. Moving to the next one, transitive relation. To define the transitivity, one should have the three elements belongs to given set of real numbers. For all a comma b comma c belongs to R, if a comma b belongs to R and b comma c belongs to R but a comma c is not belongs to R, that's why R is not a transitive. In a finite set, in infinite set, we have to give example to show that the relation is neither reflexive, symmetric or transitive. These are not only the examples which satisfies these conditions. There are the many more problems which we can define and we can show that it is not a transitive relation. Here A is 100, B is 5, C is 2. Then by the definition of transitivity, A is less than or equal to B cube. B is less than or equal to, that is what here, 2 cube. But 100 is not less than or equals to 2 cube. That is A less than B, B less than or equal to C cube. But A is not less than or equal to C cube. A is not less than or equal to C cube. That's why the given relation is not a transitive relation. You can see here, we can observe here, 100 is less than or equal to 5 cube, 5 is less than or equal to 2 cube, but 100 is not less than or equals to 2 cube. Therefore, this example is not a transitive relation. Therefore, the given relation R is neither reflexive nor symmetric nor transitive relation. Dear students, whatever the three examples I have taken today, these three examples are very important for the exam point of view, which are expected in the examination for 3 marks. These are the questions which are expected for 3 marks. I hope you have understood these examples. If you have any queries, please contact the given below number. Thank you. Stay home, stay safe.